Hi there. This is the first video in our series where we interview college robotics teams. Today we are here with.
I'm Marco. I'm the president of VT Crow.
I'm Tyler. I'm Vice President of Operations.
And I'm Maxwell. I'm the Vice President of Engineering.
Perfect. My name is Ruhi. I'll be the one interviewing you guys with Shreya. Yeah. So we're from Team Ingot Metal 5773, an FTC team here in Fremont, California. And we would just love to hear. We can start off with just if you could give a little introduction to your team, what you do, what program you're part of, and yeah, go for it.
Sure. Okay, I'll start us off. VT Crow is the competitive robotics organization at Virginia Tech, and it's the largest design team on campus. So we have about 90 engineers that work across 10 majors. But what makes VT Crow really special is that we're a very big team, but we believe in small individual teams to get engineering done. So each of our individual design teams are from anywhere from 8 to 12 people, and we have five of them. So we have a VEX team, we have a Southeast Con team, we have a manufacturing cell team. We have a autonomous vehicle team, as well as a robo dog team that's building a robotic dog. We also have an outreach program that goes to local K through 12 elementary schools. We have an operations team that handles all the finances and the travel, the stuff that engineers don't really want to deal with. And finally, we have a learning team, which hosts weekly workshops so that anybody interested in robotics can get up to speed on what we do in the design teams, so that if somebody comes into college with no prior experience, they still have a fair shot at getting into our program.
Yeah, that
That's
sounds
really
really great.
cool. So, what's some of your team's history and background?
Sure, Max, you want to talk about a little bit about this?
Yeah, so we kind of started off with one single team. It was the Southeast Con team. We go to this event called IEEE Southeast Con, and it's the small autonomous robotic challenge. So from there, it only had a couple members, and we grew from about 4 members to about 16 members. After that, in the next year, we created more teams. So that's when we adopted the VEX Robotics team, as well as going to the Intelligent Ground Vehicle competition, IGVC competition. After that, this year we started the two more teams, which is the manufacturing cell design team and the RoboDog team. So a lot of these teams kind of just go all over the United States for their different competitions, and kind of year by year we select what competitions we find are the most important or really cool, and then we can adopt those into our program, and we can create a dedicated team to tackle those challenges.
All right, sounds great. I've just what's one of the most proudest accomplishments that your team has had? Maybe it's really recent, like you guys just did something, or like throughout your entire team's history.
Well, what we're doing recently, which is something I'm very excited about, is we're hosting our second annual VEX competition here at Virginia Tech. So previously, Virginia Tech didn't host any robotics competitions, and now we have one of the largest in Virginia. So last year we had about 20 high schools come and about 12 universities, and this year we're going to have about 40 high schools, about 90% from Virginia, and 16 to 32 universities come down to Blacksburg and compete. And that's something that we are really proud that we were able to bring, because not only does it just create a cool environment and something very fun to watch, but it also kind of helps with recruitment. So if any high school teams are interested in coming to Virginia Tech, they can come to our competition and kind of tour the university. We're going to have golf cart tours of the university throughout the day. And this 2-day event is going to be something really special.
That sounds like a really, really fun experience, actually. So, with all this, what were one of the biggest challenges you guys faced while setting all this up?
Well, Tyler's really been across the operations of the event, so I'll let him take this one.
Yeah, so as usual, one of the biggest problems that faces any team is finances. That's my main area of expertise. That's my responsibility is finance for the team. And sometimes our ambitions are larger than our wallets, and we need to figure out ways to find the funds, whether that be corporate sponsors or grants or even our own personal money. We need to find that to actually do what we want to do. So, for example, when we first made our first robot, we were not a student organization. We were just a group of people who wanted to make a robot. And that was our first year. That was the first competition a couple years ago. And we had no money. So luckily we had some great partners at Virginia Tech. We had a mentor who was helping us out, and then I believe we also got some money from the school, some seed money basically to go out and do this competition. However, over that summer, we grew to, I believe, 60 members after that summer.
Yeah,
Someone
that's about
correct me if
right.
that's wrong. We went from like Max said, like 16 to 60 with 3 teams. So my life was finding money, and that was definitely the hardest part. We're still here. We are doing fantastic, and we're growing as always. But definitely finding money and being able to fund everything we want to do, fund 3 to 5 teams traveled over the past 2 years, fund an event as big as we're hosting this year, and actually buying parts for the robots. All of that needs money, and it takes a lot of people. It takes the entire operations team to get that for the team.
Yeah. I think something that you mentioned about having 60 members, that's actually something that I think a lot of FTC teams could also struggle with, just like having a huge team. Like our team has 15 members, so I'm curious, like, how do you guys like kind of split up the work? Like I know about your like 6 different groups that you guys have. So is everyone just part of one group, or can they like kind of work with multiple groups at once? How does that kind of work organizing everyone?
I think we have about 1 or 2 overachievers who are working with both operations and an engineering team, which is a crazy amount of work. So really props to them for wanting to do that. But usually all of our members are dedicated to one team. And after every year, they're able to transfer teams if they're interested in taking on a different challenge. We encourage that. But in general, everybody has about one team.
Mhm.
Hmm. Okay, that sounds really cool. So when you're designing these robots on these teams, how do you go about designing them? Like, do you use a certain design process or how does that work?
So typically how that works is we split it into like a design cycle and then a build cycle. So the ideal is that you sit down for a couple weeks and like really work out all the intricacies of the rules of every game. And then after you go through those rules, you find what the minimum requirements are to achieve our expectations. And then we design for those. And then ideally we want to like get first place. We're always achieving for first place. So we design to kind of do the most in the most simple method, the most modular method, and the most kind of cost effective and simple method. Try to really make sure we're not overcomplicating things so we don't achieve our goals. And then after we do a lot of designing, we go through a phase of buying things, as well as kind of gauging who has to do what on the team. So there's a lot of kind of human engineering that has to go down with like who's doing what and holding them accountable to those tasks. And then afterwards, we go into a really heavy like build phase where we kind of take the work that we've done in the past for the designs and then kind of put them into reality. And as you guys know, as part of a robotics team, that almost never goes to plans. So we always have to make sure that there's backup plans for that, as well as making sure that we finish the design early enough so that we can go into a testing phase. We think that testing is really important before you go to competition, so you don't show up with something you've never used before. So that's kind of our typical design process for building these robots.
Yeah, just like to expand on that, like what's like kind of the timeline there? Like when do you guys like know what type of robot you need to build, and then like when do you start designing, when do you start building, all that?
So that
Right. So
actually that shifts a little bit from team to team. So for
Mhm.
example, for the Vex team, they know what the new game is right after the previous game. So they have the entire summer to ideate and really think about their new solutions. But other teams don't actually know which competition they're going in until the first or second week of school, since we give each design team full reign over what they want to do and what competitions they want to go to. So it really depends on which team. Southeast Con, for example, they have the same structure where they get all the rules before the summer, so they get to ideate through that. And then right now they are on the build phase where they have built the chassis and they're building several different components to get the game done.
Mm.
So when you guys are going through like this engineering process, how do your teams like go about like for example debugging code or just like testing your robot?
right, I'd say that's very much on a case by case basis. I mean, like the challenges you know that happens in robotics teams. I mean, they could be mechanical, they can be code. Even on Tyler's side, they could be money issues. So I think it's really by a case by case basis. I would think that most of the time it's a lot about like communicating this with other members of the team, and then having a lot of cooperation to figure out these issues. But for the most part, I can't really say there's one specific way that we go about solving these issues.
Mm.
On
Yeah,
that
sounds
note, how do you usually go about managing your funds?
Sorry, say that one more time.
I'll let Tyler take that one. Oh, how do we go about managing our funds?
Oh, So that's been an ever evolving process. At first, it was well. First of all, we had to open up a bank account. So we opened up a bank account for the team, and at the beginning, it was we talk with amongst each other. We say, is this worth buying? Is this not worth buying? And then we wait until we see it show up in our bank account, on our bank statement, and the statements is how we tracked our finances. And that worked as a band-aid solution, but um, it did not work once we had 5 teams and we were purchasing things all the time. So on the money in side, we get money from corporate sponsors and grants from the school right now, and that basically just pops up in our bank account as it processes through the school. But on when money goes out, when we have to purchase things, we have a purchase form and a receipt form where people will, whenever they purchase something with our bank account, they will submit that through the receipt form. We can have record of that, and then they'll type it into a spreadsheet that we have, a master spreadsheet that calculates all of the expenses from every team, and pops it up onto a dashboard. So we can quickly look and see exactly how much each team is spending. And then we can get a more detailed view on this is exactly how much they spent on this date to buy this part. Um, and it takes some getting used to, but that's the system we're working with right now. Basically, just a big spreadsheet and then double checking with our bank account statements.
Yeah, and also from a team perspective, before every build cycle, they submit a list and a bill of materials of things they're going to need, and they get the estimate within a couple $100 so that leadership knows what the total spend is going to be.
Right.
Okay. So for the corporate sponsorships, so I'm actually business captain of our team,
Mhm.
and I know our team struggles with this sometimes, and a lot of other FTC teams do as well. But corporate sponsorships are very hard to get. So are there any tips you recommend for getting those?
Yeah, one word, networking. That's the biggest thing. It's really hard to convince someone that doesn't know you to give you money. And it's really hard to get to know somebody quick enough for them to give you money for your team. So it's really important to leverage any connections, any existing connections you might have. So, for example, our team mentor worked with Boeing, and he managed to get us a conversation with somebody who could get us money, and then Boeing became a sponsor for us. And then we've also been reaching out to local businesses in the area. We've had seniors graduate and go work at companies, and then they can vouch for us, and we get sponsors that way. And those have been the main sources of real solid dedicated corporate sponsors. The other way, which is a lot less successful and a lot more tedious, is cold calling and cold emailing and just getting contact information and just trying to make a good sales pitch. And that's a lot less successful. However, if you do it in a large enough volume, you're eventually going to get somebody who wants to support you guys.
We've never had much success with that strategy, though.
Exactly correct. Yeah.
Yep, I'm realizing where we're going wrong now too.
Yeah.
Yeah, I think I had a couple more design questions. Before I get to that, I feel like we didn't really ask. So like what exactly, like I know you guys have like a couple of different robots going on at like the same time. So what exactly is each one like supposed to do? Like if whether it's for like a competition or just like something that your own team is doing.
Sure, yeah, I could take this one. So, the manufacturing cell team, let's start there. They're building something for the National Robotics Competition, but they're also building something that they're going to keep in the lab forever, and that's a 3D printer that is able to take prints that are done and store them using a gantry system onto a shelf. So that way you can queue prints that can go overnight. So right now, when you print something, right, once it's done, you can't really print another thing until that thing's gone. So that means that if you do a print at 4 p or at 8 p.m. that's going to take 4 hours. That means at midnight you have to get up and take the thing out of the printer. So they thought of a way to sidestep that entire process, and they are building a machine that does all of that. And what we found on the internet is that these things cost about $80,000, and we're going to build it for about 3,000. Another one is the robot dog. So exactly how it sounds, we are building a dog that is able to autonomously walk, and this is using four legs that are going to be attached to the body of of the dog, and then we're going to be 3D printing the exterior of the dog to make it look a little bit realistic. Um, Max, do you want to take Southeast Con and Vex?
Yeah, I can do that. So for the Vex, they go through a different competition every year. So they're just going through the university requirements. I know the VEX university requirements are a little bit different than the high school and middle school ones. So in the university, you actually build two robots and compete with two robots. So they're actually building two robots at the same time here. And there's a third robot that's actually being built for the skills challenge in VEX as well. And for the Southeast Con, the rules are you have to make a 1 foot by 1 foot by 1 foot robot. So pretty small, but it has to be completely autonomous. So all of its movements, actions, and decisions have to be made by, using sensor data or external data that we can collect. And it has to complete a couple of challenges. Last year, it was like jumping over like a little hole in the floor and picking up some blocks. So it changes every year, but it's pretty fun and often requires a lot of manipulation. So that's really cool. And then we
And
also have the IGBC team.
yeah, we have the AutoNav team, which competes up in Michigan, and its job is to make an entirely autonomous vehicle. So this vehicle is completely custom CNC'd and has a completely custom chassis. And we have a LiDAR sensor and a couple different subsystems to make it run completely autonomously around an entire track. So that means stopping at stop signs. That means navigating with GPS sometimes without even seeing any road markings. It's a really complex challenge, but the team this year is just killing it so far.
Mhm. Yeah, that makes sense. That's really cool. For specifically for the two robots that your team yourself is creating, like the robot dog and the 3D printing one, are you guys, what's your like ultimate plans with that? Like, will you maybe like make more to like give to other people as well, or is it kind of just like a just for your team?
So
Well,
I can answer on the robot dog part.
oh yeah, sounds good.
Yeah. So for the robot dog, a lot of this it achieves two things. One, it's something that we can go to competition with and compete with, and then secondly, we can scale this design up and actually make this a fun robot that whether it be children, the elderly, or anyone we're interacting with at volunteer opportunities, they can have fun with this thing. It's something that's much more approachable than something with a lot of gears and wheels all over it. When it's a dog, you can go over and play with it. And it even allows people like children who, they love to drive robots whenever we're at these volunteer events. So they can even drive like the little robot dog if they so choose. So, it really kills two birds with one stone there.
Yeah, and then for the 3D printing project, so we plan to have that in the lab forever, and a part of that is actually building a website so that it's like a portal where you upload any of the 3D prints you want, and then it just like queues it, so it could be used for the entire team, and that's going to be really an important part of the lab that's going to be going forward forever. However, next year we don't really have plans to continue working on something like that or making another one. That's going to be up to the discretion of the new chief engineer of that team, and they can take the project in whatever the way they want.
So like, do you guys make a new project every year, or like, how'd that work?
Yeah, so that's also up to the chief engineer. So the way our team's structured is that we have 5 different design teams, but each one has their own chief engineer, and that chief engineer has full reign over what the team does each year, and who's on the team and things like that. So from a really micro level, you can see like 5 different independent design teams that can all go in their different directions. And as leaders, we don't enforce a certain policy about what they should work on.
So I know one of you mentioned something about outreach as well. So how do you go about planning those outreach events?
Sure. Yeah. So we have a VP of outreach, Frank, who's fantastic, and yeah. So he works with Seed and he works with different organizations on campus that have connections with local schools, as well as calling local schools directly. And we schedule whatever sort of events we can. So, for example, we talked to a robotics club. We went to different fairs where we can show off the robot and kind of get kids engaged that way. And we are also planning like a workshop for high schoolers so that they are able to kind of get the basics of robotics before they go to college and have to pick their majors and everything. So we get involved really any way we can, and that's up to the VP of outreach to make that happen.
Okay, interesting. Do you guys have any ongoing things that you're kind of working on for outreach related activities or?
Ongoing. There are schools that we go to yearly events for, and they're all planned. So, for example, there's one down the street that we do 2 events per year at, and Those are our school relationships, and then there would be the VEX event, which is just a very large event. We have a ton of outreach that's going to happen there, and that's also a systematic way we have of keeping that community engagement alive.
Yeah,
Yeah,
interesting.
I think that's it for the most part. Do you guys have any questions for us or?
Anything else you want to say about your team or let the viewers know or let us know?
Mhm. Well, I would like to talk a little bit about founding a team. And when you're founding a team, everything seems like incredibly scary and like there's like a million options you have to do, and no one's really telling you what to do either. So you really have to go out your own and just do whatever feels right for the team. And it's a really daunting task, but anybody who's in a position to start something new, I would encourage them to just try it out and do it.
Yeah. And structure it in a way where you're just doing what you want to do. This is kind of how I've kind of looked at it. Do what you and your friends want to do. Find a group of people, start doing it, and then figure out how it fits into the actual system later on. Like we started making a robot, we went to competition before we were even a real recognized club or organization. And then we built ourselves into a kind of organization that's never even existed before at our school. And we had to work with the school on how we can actually exist. So we wouldn't have been as successful as we are if we hadn't just gone with it and trusted each other to do well, and then figured out the annoying, systematic stuff later. Um, just do what you want to do and enjoy it. That's the biggest thing.
Yeah, absolutely.
Yeah, definitely. All right, if there's nothing else, then thank you guys so much for meeting with us today. I think we learned a lot of really cool things about your team. And yeah, we hope to see you guys another time.
Yeah.
Yeah, sounds
Thank you
great.
Thanks so
so
Thank
much.
you
much.
so
Awesome. Thank you,
much.
guys.